Hello, this is Brian from the Marlowe team, and I'm going to be demonstrating a Marlowe contract for invoicing that automates the invoicing process using an Internet of Things device. Before I show the demonstration, I'd like to talk a little bit about the architecture behind it. We're going to be using an IoT device called the Broen Object Locator. This reports GPS position, temperature, movement, and it has a button that sends a binary signal. This is deployed over a very low power wide area network that is connected to the Helium network. And from the Helium network blockchain, we have an HTTP connection to a Marlowe Internet of Things Oracle. This is a data aggregator for purposes of the invoicing. And that has a TCP connection to the Marlowe runtime backend, which is a collection of Marlowe services, which then talks to the Cardano node. So all the data from the sensors is coming in through this path onto the Cardano blockchain. Simultaneously, we have another instance of Marlowe runtime services running against a different Cardano node, and connected to that is Marlowe Lambda, which is a Marlowe runtime client for AWS Lambda. So we have this deployed in AWS Lambda. It's actually at a data center in Paris. And then web browsers can easily connect to AWS Lambda services. In the demonstration, we're going to be having a supplier and a purchaser that take part in the invoicing process. So they have their own web browsers, and they use HTTP traffic for the Marlowe Lambda. And that Lambda could be deployed in multiple places. There's no actual centralization that is necessary. It's just convenience to run this in one data center. So there could be redundancy there. So now let's show you the front end of the application. So these are the web browsers. And here we have a view for the accounts payable. So this is for the buyer. And then they can reject an invoice or pay an invoice. We also have a different view for accounts receivable. They can cancel an invoice or submit an invoice. So the data aggregator is going to be adding lines to the invoice, and then either the buyer or the supplier can take action depending on that. And I'm going to be demonstrating this with two tabs of the same web browser, but these could just be on different machines. There's no requirement that they be running on the same laptop. It's just convenient to do that when doing this demonstration. So the data aggregator initiates the contract. They're trusted by both the supplier and the buyer. And as you can see here, we have the beginnings of the invoice. So this just has the parties involved, their addresses on the network, and the transaction that created the contract. And the view for accounts payable is just very similar to this. So now we're actually going to create an event using the sensors. So I'm taking this IoT device. You probably can't see it, but there's going to be a little flash when I push the button. And that's going to actually go through the Helium network to the bridge between Helium and Cardano. That is the IoT Oracle for Marlowe. So here we see the event that I just created. Just notionally, it's described as loading unloading services for this demo. But you can actually see the event ID, the event type, the actual sensor ID, the timestamp, and then the transaction on the Cardano network that recorded that. So I'm going to create another event. So this one, hopefully we'll just get a motion event out of this instead of a button press. Maybe I'll do a button press too, just in case. And so we'll wait for this to propagate through the network. Okay, so we see a second event, and this was a little bit different because I didn't push the button, I just moved it. You can see once again the sensor data. There's a fictitious cost that's associated with this that is just made up. And we'll wait to get one or two more events here. Okay, so in real life you would have many different types of sensors, and they would be more thoroughly curated than me just waving the sensor and pushing buttons. But this kind of gives you an idea of how the connectivity works and how things move over the networks. Once again, we see that the accounts payable has the same view. So now let's say that it's time to submit the invoice. So the accounts receivable is going to submit the invoice, and then we have to wait. You see this is on the blockchain awaiting confirmation. That takes about 20 seconds on average, but it can be faster or slower for the Cardano network. And now it says awaiting payment. That means it was confirmed. So let's take a look at accounts payable. And now we can see they have an option either to reject the invoice or pay the invoice. Either rejecting or paying are recorded in the Marlowe contract on the blockchain. So for this demonstration, we're going to actually pay the invoice. Once again, we're waiting for confirmation. We'll see the result there. So this is actually paying 38 ADA from the wallet of the accounts payable. It says it's paid in full. And then we can actually take a look at this on the blockchain. So we're going to visit a blockchain explorer. We have the addresses of all the parties, the contract ID for Marlowe, and then the most recent transaction. So this will be the payment transaction. So we're going to go over to take a look at this. This is going to take a second to appear. So I'm just going to refresh. The online explorers take a little bit longer than just the nodes to see the transaction confirmed. Okay, so then we see the transaction. We'll just scroll down. This indicator means that there were funds in a smart contract, and here we see the actual transfer of the 38 ADA. And you can actually go back and see the previous transaction here at the script address. And then we will look at the transaction previous to that. And what I want to do is show you the metadata. So you can actually see the data that was put on the blockchain that we displayed in the invoice. So I hope this gives you an idea of some of the things you can do by combining IoT devices with Marlowe contracts on the Cardano blockchain. This is a kind of a mostly trustless system. All the software stacks can be operated by the different parties. Of course, the supplier and the purchaser do have to trust the data aggregator, that they are appropriately aggregating and reporting data from the sensors in the field. So there's a point of trust here. And thank you very much.